Hi, everybody. Thank you for joining this workshop today. We are happy to have you here. Today, we have Jayashilan Kumar, who is a principal member of the technical staff at Oracle, and he will be talking about deploy OCI services from Kubernetes. So over to you, Jayashilan.
Hey, hi everyone. Hello, good morning, good afternoon. Today we'll be talking about how to deploy or how to provision an OCI service from Kubernetes. What are the tools we have, and how can we do this? So let's get started. So today's agenda is a very brief introduction about myself. Then what is OCI Service Operator? What is it based out of? What is the entire reasoning behind why do you need an operator? And then we'll also talk about Oracle free tier signups, then the lab session, which we have all assembled here for, and the Q&A. If you have any questions, we can walk through. So I'm Jayashilan Kumar. I'm from Containers and Kubernetes Services org, and I'm part of OKE Foundations team. I've worked on multiple components in OKE, and I've contributed to a few open source Oracle projects as well, like OCI Service Broker and OCI Service Operator now. I've been with Oracle for 6+ years and in OKE team for 3+ years. I'm basically based out of Bangalore, ITC. So this is a very brief intro about myself, and let us just get on to what is OCI Service Operator. So what is operator in general? So Kubernetes has a concept called operators, through which you can extend the Kubernetes APIs and make it do some custom work. This work can be done by any human operator, and you want to automate it, and you want to use a certain way and tell Kubernetes to do these operations for you. This is basically the operators concept. And Kubernetes has come out with the framework. The CNCF has come out with a framework for this called as Operator Framework. And that is a standard today. A lot of cloud providers are writing their operators based on this framework. And our OCI Service Operator also is based out on the same framework. So why an OCI service operator? So as we all know that operators is to extend beyond the Kubernetes API's core components. Our entire idea here is have a group of operators under OCI service operators where each operator will help you manage individual OCI services. Like today we are onboarded to autonomous databases, MySQL DB systems, and streaming services. There are a bunch of other services which are being built in pipeline. But we are going to be helping customers to use this operators, OCI service operators, and go provision or manage these resources in their OCI cloud. So that is the main reasoning behind this. And what is the help? What is the value add it has for developers, right? So like developers today, container native developers, when they're writing their apps, they also need some of the services, right, which has to be provisioned and managed. And today, the experience is very disjoint. So what we thought was, what if everything is under a single YAML, where you can actually write a YAML to go create a database. You can write YAMLs to update it, do all the operations with it. So that is the major reasoning behind why we wanted an OCI operator. So this is a very brief introduction about OCI service operator. We call it as OSAC in short, so that it's easy. And OSAC is both can be run on an OKE, which is Oracle Container Engine, or in any other Kubernetes cluster. So there is no specific vendoring here, like you can run it in either places. So yeah, that's a very short introduction about OSAC I had. And let me move on. So this is the free trial OCI cloud account. So I would request the participants to scan this QR code, go to this and sign up for this account. This will be used extensively this will be used in our lab session. So this will be the account where you guys will be doing your lab on. I think if at all we have scanned it, and if we can move forward, I can go to the lab session. So yeah, I'll exit my PPT and take up the content of the lab. Okay. So yeah, we quickly saw about what's OSOC and what is the entire uh, framework about and what is it used for. So we'll see most of it in action today. So we will help you guys to actually go create an OKE cluster, and on an OKE cluster, we'll also give you instructions on how do you install the deployment tool of OSOC, which is called as Operator Lifecycle Manager, and then we'll install OSOC on your clusters. And then we'll try to provision an MySQL DB system and an autonomous DB system. So this will be an overall rough agenda of what we will be doing in the hands-on today. So let me get started. Yeah, so a prerequisite is Oracle free tier account and familiarity with console, and CLA options to install on the local machine. Okay. So yeah, I think once you scan the QR code, you would be landing on this page. This would this has all the detailed instructions where you'll have to be providing your account info, country, first name, last name, your email, and once you click on verify email, you should be getting an email. It'll actually verify if you're a human, and then you'll be getting an email to your mailboxes. And once that is done, I think you can click on it. You will have to enter these additional values. It'll open up the same box with pre-populated email address, first name, last name. You will have to confirm password, company, cloud account name, which is going to be your home region, and other things has to be chosen, and your address information has to be chosen, the mobile number. Yeah, it's mostly self-explanatory, and you'll have to add the payment info. And then, yeah, after you are going to be done with provisioning, your account is going to be provisioning. So it will be individual things where you will have to be doing each step, and it will take you to the next step. And finally, once everything is done, you will have something like this, and you can move on to step number 2. So here you have to, whatever the tenancy name you had given while provisioning it, that will be the tenancy what you'll use here. So cloud account name, this will be the cloud account name what you will be using as part of step number 2. So please provide the cloud account name what you have used earlier. And when you click on next, so this page will be shown based on whatever is going to be a cloud account name. You will have to select this from the top drop down and click on continue. And this is a place where it'll ask you for your username and password. Please do enter that. And once you click on sign in, you should be taken to this page. This should be the landing page of your OCI free tier account sign up. Okay, I think yeah, the 1 minute is up. Let's move forward. Let's go to the next part where so in this exercise we will be creating an Kubernetes cluster, and you know that Oracle offers a managed Kubernetes cluster for us, and you can actually go provision master node. You can go provision worker nodes there, and master nodes are maintained by Oracle, and it helps you to take care of upgrades and all the other things, all the value adds. So without wasting time, we can get started with the step number 1, which is create Kubernetes cluster. So in your home page, which we saw in the previous exercise, you will have to go to the hamburger menu at the top corner, and there you will find create containers under developer services. So you can go and select this container clusters under that. So all the policies are pre-configured, so you don't have to be worried about any policies for OKE today. So it is all pre-configured for you in the created account. And once you go to that, you will be entering a landing page. And in the landing page, under list scope, you can pick the compartment where you want to go and create this cluster in. So I think it will be your root compartment, which is the name of your tenancy, or the cloud account name will be the default name in it. And you can choose that also to actually go create a cluster for yourself. And at the top, outside your hamburger layout, there is a create button for you to go click on it. And there you can choose quick create, where most of the things will be created for you by default, and click on launch workflow. So once you do that, these are all the basic things what you will have to be filling out. I can talk about it. So this will be the name of your cluster, and this will be the compartment. As I said, this will be the tenancy name and cloud account name, and that will be the root compartment. You can choose a Kubernetes version. I think it is good if you can choose 1.22.5. And also, this is to keep your public API endpoints, Kubernetes API endpoints, and Kubernetes worker nodes. So you can choose a public endpoint, or you can choose between private workers and public workers. That's a choice which you would want to. If you choose a public workers, you will have external IP addresses associated with it, which you can use to SSH. And then there is advanced options where you can give your SSH key, and then you can click on next and create cluster. You will have to choose a number of node pools. So please ensure to choose a single node so that it is easy for you to get everything under a same node. Yeah, so this is defined here. The shape, try to choose an AMD shape, because the operators today have some issues with ARM shapes. So try to choose an AMD shape for your worker node. And once you click on next and create cluster, you should come to this page where a bunch of components will be created for you in the background before the create cluster and create node pull requests are fired, like your virtual network, virtual VCN, your internet gateway, NAT gateway, cloud table, checklist, subnets. All of these will be created in the workflow, followed by create cluster and create node pool. So once you are done with this and you click on close, you will be going to the clusters details page of the cluster, what you created now. And we'll have to wait for the cluster to become active. I know it will take a couple of minutes there before the cluster becomes active. In the meantime, I at least can move on with the CLI things. I think you would have installed OCI CLI now. This is mainly required for you to download the kubeconfig into your machine and use it for the other exercise or other rest of the session where you will have to run some of the commands. So I think as part of prerequisite, we have installed our OCI CLI. So yeah, OCI-V will give you the version of the CLI what you guys are using. And once that is completed, you can install kubectl. So these all things can be done as our cluster is getting provisioned. So you will have to make a directory using this command. You can use copy button here and try to make that directory. And once you are into this directory, you can use kubectl version. So here 1.15 is used. You can use 1.22 as well, whatever is the Kubernetes version you are using. So you can use that version to download. This is a Windows installation. So it depends on what will be the default machine you are using or running this session or lab in. So please feel free to use that particular version. And once the download is complete, you can verify and install it. So yeah, and we can get the kubeconfig and initialize your environment. And I will give a minute for us to wait till the cluster gets provisioned. And once that is done, we can start step number 4, where we will have to be going to resources and into the window and navigate to the cluster. Uh, and there you will have a place where in the quick start directions will redirect you to copy paste this command as shown in your local terminal. So yeah, please feel free to post your questions in Q&A, and we will try to answer it as we go forward. So I think I'll give a minute here and before we proceed to the next section. I've shared the live labs URL, and I think we had a bunch of questions around it on how do we access it, and regarding the quick recap here. So yeah, I was mainly talking about OSAC. So OSAC is an operator for OCI services. We are having a group of OCI services what we support under OSAC today, and we are having a lot of services in pipeline being built to be supported. Why do we need it? We need it because from Kubernetes, from YAML files, you will be able to provision and manage OCI resources. That's the major advantage what we get. You don't have to be switching between console, CLI, Terraform, and a lot of other things. So the thing what we write our container native apps with, what we are very familiar with, that can be used to actually go management OCI resources. So that's the major advantage of using OSAC. And we just got started with the lab. So I just completed two sessions, or like 2 parts of it. So the first part is about Oracle free tier account, where you will have to be opening up and creating an Oracle free tier account for yourself for this lab. And once the account is created, so the instructions are part of this. In the getting started, in the introduction, we have all the steps needed for you to go create an Oracle free tier account. And it also talks about what are the fields which is needed, and it has a lengthy process with respect to sending email, verifying the email, and all the other things. And once you are done with creating of the account, then you will have to sign into your account. For signing in, while creating the account, you will be giving something called as cloud account name in this page after verification of email. Please remember this cloud account name that will be used in your sign-in process, where that will be the value what you will have to be provide here. And then when you click on next, you will get a page where you can choose this Oracle Cloud Identity Service as your from the drop down. There will be one entry. Please choose that and enter your username, password, and you should be able to come to the landing page of your free tier account, Oracle Cloud free tier account. So yeah, I had given some time for this in the past, like where people can go in and create the account for themselves. Now I'll move to the next part. So to start off this lab, we need a Kubernetes cluster. So we will be creating an Oracle Container Engine Kubernetes cluster. So that is lab 1. In the lab 1, what we will be doing is there are instructions for you to go create a Kubernetes cluster inside in your homepage, in your landing page. In the hamburger menu, go to Developer Services, and you should see OKE Kubernetes cluster. So please click on that. And once you come to that page, there is at the left side, there is something called list scope. You have an opportunity to select the compartment where you want to create this Kubernetes cluster. And the default one will be your root compartment, which will be named same as your cloud account name. Now, please select that. And then there is a blue button for you to go and say create cluster. And as part of the workflow which gets launched, use quick cluster and then launch the workflow. This will require very basic inputs like the name of the cluster, the compartment which will be pre-selected, And the version again will be the latest. If you want to go back to anything, it's okay. I would recommend using 1.22. And you can also pick the K8S API endpoint. Try to keep the K8S API endpoint as public. And for your worker nodes, you can choose between private and public workers. So that is a choice what you have. Keep the number of nodes as one. And shape, try to choose an AMD shape. ARM shapes have some known issues with the operator framework. So tries to use an AMD shape here. And after you have done all of this, you can click on next and then go and click on create cluster. As part of the create cluster, you will have a bunch of resources which will be created by the workflow, like VCN, Internet Gateway, NAT Gateway, route tables, checklists, subnets, and finally create cluster and node full request. Work request will be launched, and when you click on close, you will be taken to the cluster's detail page where it will show us creating there. When the cluster is getting provisioned, I think as part of the prerequisites of this session, we had asked for you to install OCI CLI and configure it. So please ensure, like when you run this command, the version should be 2.24 and higher. Please ensure your OCI CLI version is higher than 2.24.x. And after that, you will also have to have a kubectl installed in your machine. And you can create or follow the instructions in this particular step 3, task 3, where you'll make a directory for storing your kube config. And then you can actually go in and download kubectl exe and run it. So if you're using a Windows machine, it's an exe. And if it is any other machine, please use a suitable kubectl for the installation. And once it is completed, you might have to go and get the get kubeconfig.ssh to initialize the environment. So this is Windows machine based. So the commands given here is specific to Windows. So I had given time in the past for people to do this. So yeah, I will. Yeah, since we have already spent some time here, I would like to go to the next section and talk about how the installation of OSOC is supposed to be done. I hope by now your Kubernetes cluster should be up and active, and your kubectl should be there, and you should be able to access your Kubernetes cluster. So one quick way of verifying if at all is your nodes, worker node what you provisioned as part of the Kubernetes cluster is up and running. You can use the command what I will give in the chat. Please run this command and you should see a single node listed there as ready. That would indicate that your cluster is completely active and ready for it to move on to the next step. So I have a few questions here where Abhijit has asked me that India West is not having container clusters. Can you search for OKE in the search box there, and you should have something called Kubernetes or clusters, something like that. So that would help you to create it. And are all these features free with OCI free tier account? Yeah, I think yes, it is all there with the OCI free tier account. So yeah, I'll move on. For us to install OSOC into your cluster, you will have to install Operator SDK into your machine. And in the link which I shared before, there is a link for you to actually go and look out for the instructions on how do you install Operator SDK into your machine. This has details on how can you do that. So I have Bhavesh Agarwal asking me about what is the link for kubectl in Mac. I'll give it to you shortly, Bhavesh. Yeah, so I've shared the link in the response to Bhavesh. So yeah, here when you're using Mac OS, you can use brew to install operator SDK into your machine, or you can go construct this URL and based on the OS and the architecture of your machine, you can construct this and download the operator SDK and into your machine. This is a step, you can skip this step to verify the downloaded binary. Mostly it will be fine. Uh, Once you are done with the download, you can move this, you can run this command to make it an executable and then move it to your user local bin to make it into default thing. You can make it run in the path, you can set it in the path and it will be available and accessible to you. So once the operator SDK is available, so we can move on to the next step where we are going to be using the operator SDK, install OLM into the cluster what we created. So a step what is missed before this is, I'll put it again in the chat. Uh, you will have to export your kubeconfig into the terminal what you are working on so that operator SDK knows which is the kubeconfig you are using. So you can use this command what I'm giving you in the chat. So by this, we are setting a kubeconfig in your terminal and all your operator SDK commands and all the other commands what you will be executing going forward will be pointing to that particular Kubernetes cluster. So yeah, once we have done that, and I assume we all have installed kubectl and it is ready. So we can uh, start with this step, task 2, where we are going to be installing the operator SDK. Using operator SDK, we are going to be installing Operator Lifecycle Manager, OLM. Why OLM? So we will all be more familiar with Helm, right? So as part of CNCF standards, Operator Lifecycle Manager has a much more advanced support for operators written using operator framework. And that is the default standard, which is practiced by CNCF for installing operators onto your cluster. It has a lot of advantages and it takes care of upgrades and rollbacks in much more clearer way. Okay, is my voice not clear? Is anyone having any other issues?
I can hear you.
Okay.
All okay.
Okay. Yeah, I'll move forward. Okay. So once we use operator SDK once we install OLM, it will go through a lot of installation steps. It will take a few minutes before the installation is complete. And finally, you should be seeing this message, which says install the latest OLM version into your cluster. Once you see this message, this means to say the OLM installation is successful. Then you can run this command in your cluster to check the status of your OLM, which got installed as part of previous step. So this is a version which was used while creating this tutorial. Might be when you had installed it using this step, you might get a newer version. So that is okay. That should be fine. So ensure that you get an output very similar to this. And once this part is complete, is the important part where we will actually be installing OSOC into our cluster. So OSOC supports two types of authentication authorizations today. One is instance principals and the other one is user principals. So for easier approach to the tutorial or the session today, I would suggest you guys to use instance principles. And this is the process on how to enable instance principles in your worker node or the OKE node, what you are provisioned now. So go to your hamburger menu or there is another way. Okay, so step number one is to get your tenancy OCID. So please follow this step where you can click on your profile on the right top corner, and there you will have your tenancy name. That is nothing but the cloud account name. Click on it and it will take you to the cloud tenancy details page. And in that you will see something called as tenancy OCID. So please copy that OCID and keep it handy or save it in a notepad so that you can use it in the next coming steps. So once this is completed, the next thing what you will have to do is in the hamburger menu, select identity and security, and under identity, click on dynamic groups. So when you click on dynamic groups, you will go to the summary page of dynamic groups. There you can say click on create dynamic group, and then you will have a page very similar to this. So you will have to give a name to the group. Try to keep this simple because this will be used in the policies what we will be defining for multiple resources when we are trying to provision them. So you can keep it very simple for you to be using it in the future purpose, but you can give an elaborated description about what is this entire group for. And there should be a matching rule, what you will have to be giving here. And just ensure that the matching rule is having this format. I see some issues with the format what is given here, where I see this thing being repeated, and this open close flower brackets as well repeated. So stick to the one what you actually have in the image. There is also an example given to you if you have multiple compartment IDs, but I would say you can use the value what you have here. I can highlight it. So please stick to this rule. The format is exactly this one. So here you will have to be giving the tenancy ID, what you copied in step number one. Once you are done with this rule definition, click on create. And yeah, once you click on create, your dynamic group is created for your compartment ID. Why we gave the tenancy ID is we said we are giving it for the root compartment where we are creating our cluster. So if you have created your cluster in any new compartment, please ensure that you give that particular ID here so that it has access to all the things what we do. I'm skipping the enable user principles here. Or I can walk you through very quickly on what exactly how different it is. So user principles is where when you create a user, you have to go and you will have your own OCID, and in that OCID you will have all the parameters like fingerprint. You might have to add an API key and create and add an API key, and passphrase for the private key, public key. All of these things will be present. You need to fetch all of those values. I think the detailed steps are provided here, and then create a Kubernetes secret with this format, whatever is shared, where the values what you see in the flower basis has to be replaced with the values what you have. And once this is created, this would act as a source of truth or like your authentication secret, which will be consumed by the OSOC when it gets deployed. So here we have a namespace to give information about. You can also make it namespace. So if you're following the namespace here, try to ensure your deployment also is in the same namespace as what your secret is created. Or if you don't give a namespace, it will get created in the default namespace of your Kubernetes cluster. So coming on to the actual deployment of your OSOC into your cluster. So this is the command what you use to pull the image. So this bundle image is what is the input for your OLM, which we introduced sometime back, which we installed sometime back in your Kubernetes cluster. So OLM is Operator Lifecycle Manager. It takes a bundle as an input and tries to run it. So please download this image where we have published our OSOC as part of this image using Docker pull onto your machine, and then run this command of operator SDK, and just you can copy paste this command into your machine And once you have run this command, it will take few minutes to install the bundle into your cluster. And once the installation is successful, you should be getting a message very similar to this, which says OLM has installed OCI Service Operator v1.0.0 into your cluster. So yeah, I think I'll give a minute here for us to go through or execute these steps in the cluster, and we can move to the next steps after that is completed. Okay, let me move forward. So what have we done here? A quick recap. We had created a OKE cluster and worker nodes as part of lab 1, where we created an OKE cluster, ensured what compartment it runs in, all the subnet config and other things. And after the OKE cluster was created, we also tried accessing it from our machine. And in the lab 2, we have installed OSOC, that is OCI Service Operator, into that cluster. Now, after you finish your lab 2, so OCI Service Operator should be running in your cluster. How can you check it? Based on the namespace, what you have installed, this particular ran this command in the last command. If you have this would run it in the default namespace. Let's say if you have used any hyphen in namespace here, you have to go and just do kubectl get pods, and that should give you the OSOC pod, controller manager pod running there. That is a quick verification to see if everything is running and there are all things good. So after we have installed OSOC into our cluster, let's go to the next one, where we are going to be trying to provision a MySQL DB system. So very quick intro about a MySQL DB system is MySQL DB system is a fully managed database service that lets the developers to quickly develop and deploy secure cloud native apps. It is integrated with Oracle MySQL OSOC, OCI Service Operator, and there is a bunch of policies what is required for you to allow OSOC to go and provision MySQL DB systems on your behalf in the OCI service. These are the policies what is needed, and the dynamic group and this thing what you see in this flower basis should be replaced with a dynamic group what we created as part of lab 2 when we were creating a dynamic group to enable instance principles. If at all, let's say you are not using instance principles and you chose to use user principles, this definition would slightly vary, where it will say allow user, or if you choose to group it under a user group, so it will be allow group. There are helpers for you when you are trying to go create policies. So for now, since I told initially, let's focus on instance principles. So this lab will be more helpful. Here we have discussed or given you instructions for you to provision or add a policy based on instance principle dynamic group, and we are giving these many permissions for the subnets and VCN reads and compartment inspect. All of these are default permissions which is required by MySQL for it to do a lot of activities at the back end. And in addition to this, you have to allow OSOC dynamic group to manage the MySQL family in your tenancy. So this you can directly paste. So this should be okay. And let's say if you wanted to be compartment based, so you can pick the compartment and give the compartment ID as well. So there are help in create policy, which you can use to change these policies and make it more restrictive or more wider as per your need. And the next thing is we are also allowing the dynamic group to use tag namespaces in the tenancy. Mainly, if at all you are trying to attach tags to the MySQL DB system, what you are creating. So we are allowing this dynamic group to use tags in the tenancy. So this is like a prerequisite for you to before go get started in creating an MySQL DB system, the OCI. So once this step is complete, so I think yeah, the navigation is very similar to dynamic group under identity and security. Uh, Under identity, you saw dynamic groups. So at the same place, you will be seeing policies. Please create a policy and add these statements there. Initially, the default thing is there will be a policy builder, which will have a drop down and other things, and you will see a toggle button there. Please use the toggle button to use manual, and you can add these rules one after other. And just ensure that you can add one, you can save, and then you get, once you save that rule, then there will be a button to add new rules to it so that it's easier for you to access it that way. Policy builder is little complicated, I would say, but yeah, for you to directly use this, please use manual and try to create these policies. Once you are done with these policies, yeah, and please note this. So if there is an issue with the policy, you might get authorization failures, 404s, and other things when you are trying to create MySQL DB systems through custom resources. So please make sure that these policies are in place and is pointing to right tenancy and right dynamic group. And the dynamic group is pointing to the right compartment where your worker node is currently provisioned. So coming to provisioning of a MySQL DB system. So to provision a MySQL DB system, right, we need something called an admin secret to be passed in the request for your MySQL DB system. So generally, this is given in the console. What we have done is we have created a secret. We ask the users to create a secret, and you can use this YAML format to create a secret. Please give an admin secret name to it, which can be used in the CR, MySQL DB system custom resource later on, and use your base64 encoded username and password. And a small note to the people with Mac, if at all you're using your terminal and trying to do encoding with that, Mac by default uses a new line when it encodes a particular string as part of the base64 encoding. So when you're using the same password while trying to log into your MySQL DB system, it might fail because a new line is added. So I would suggest you to either use an online base64 encoder decoder, or you can try to use it by creating a small Java code or something where you can generate the base64. Online thing is much more simpler. You have online formatter, base64 encoder decoders available to you. So for example, let's say if I username is admin and a password is admin@1234 dollar something. So you have to use that string, get a base64 encoded version of it, and use it here, similar to what you have. Similarly, use the username as well. And once this is created, there will be a file what you will be putting it in, and run this command with that file name, and this will create a secret for you. Once the secret is created, we might have to take the subnet OCID. So here, the subnet OCID, you have to come to the cluster details page. And in the cluster details, you have on the left corner something called node pools. So select node pools, and based on the node pool name, by default, it is pool 1. You can go to the respective node pool, and in the node pool, it will be pointing to a subnet. So this diagram will help you to locate it. And you can see that this is the subnet, what it is pointing to. When you click on the subnet, you will be taken to the subnet details page, which will have an entry very similar to this subnet OCID, which will actually be an OCID of the subnet. Please copy that subnet OCID and save it in a notepad so that it's used when you're trying to create your MySQL DB system. So this is a sample YAML, what we have shared in this link. So you will have to be using, substituting the value of individual things in this YAML And this will help you to create your MySQL DB system. And it is almost very similar experience to what you see in console. We have not kept things really complicated. Uh, I can quickly run you through on individual things what is needed. One thing to note here is MySQL DB system comes with something called as pre-configured configuration IDs, where I think I can open it and give you a small glance of how it would be. And individual configs. So yeah, this is how the configs look today. So you have the shapes and all of these things present in your system. This will all be pre-configured. If you go to MySQL DB systems, like under the hamburger menu, uh, okay, under the hamburger menu, you will be able to access configurations. I think this talks about, this will directly take you to the console where you can go in and check the hamburger menu directly. So there you can go get the configuration. You can pick a default configuration what you want for this particular MySQL DB system and take the OCID of that configuration. So click on it, it gives you an OCID. Please take that OCID and you will have to use that OCID here. This is the way how MySQL DB systems is provisioned today. When you are using console, it comes pre-populated in a drop-down list. But here it comes up, you will have to manually get it and add it here. One thing is, I have seen this OCIDs remain constant. They don't keep changing. They don't keep updating it. So once you create it, you should be good. You will not be have to repeatedly modify this. And rest of the things is pretty straightforward, where you will have the compartment OCID. We'll have to give a name for your MySQL DB system, the shape name, what you wanted, and the subnet OCID, what we copied from step number, I don't know, yeah, we copied previously, and the availability domain. If you see here, we have something like an AD1 with a value. It says ULQR and the region and the AD. So very similarly, each of us will have different values. So you will have to be very specific. You can pick up the AD what you want, place this in, copy that entire value and put it here in the availability domain. And here comes the interesting bit where admin username and admin password. So the password, the secret what we created before, and we gave a name to it. You have to use this password secret name here. So we have kept it open. You can create a single secret with username and password, or you can have two different secrets with just username, just password, and give the respective secret names here. And this will be your access credentials for you to be using this MySQL DB system in your application. And a description about this MySQL DB system, or what's the purpose of this being provisioned. And the data storage size in GBs, typically a default value is 50 GB. But yeah, please feel free to type the value what you have. And the port and the port text. So this is something specific to DB system. 3306 and 3306X is what is the default values which is being used. So we have a sample YAML which has all the things defined for you, very similar. So this XX is actually the 4-digit unique character what I told about sometime back. So you might have to give this. This is a bit truncated. You don't see the last 5 parameters here. So yeah. Okay, if I can quickly show you. So yeah, this is how the last 4 parameters looks like. So it is 50 GB, port is 3306, 33060. So this is again a sample. And yeah, once that is done, once your YAML is ready, you can apply the YAML onto your cluster. And once this is created, you will be able to see that when you run kubectl get MySQL DB systems. So MySQL DB systems is a new custom resource, what we have defined as part of OSOC. And this has logic of how do you provision it, how do you update it, how do you get it, all those is embedded into the OCI Service Operator, OSA. So this is something what we have created, and it's a custom resource. So when you do this, you will be able to get the name of what you had defined here, uh, and the status of it, either provisioning or active or updating, whatever is the status, and the age of the CR. It is not actually the age of an MySQL DB system. So this is the age of the CR. What if you want more details about this? So in such a case, we do have something called -output wide, where you have not just the name of the custom resource, but also the display name of this particular MySQL DB system, along with the OCID of your MySQL DB system, if at all that is handy for you to use it in some places. So get with -o wide would give you more elaborate details. And when you describe this CR, you will see events on what is actually happening and what are the various things, what are the various events which is going on, where is it, it's in provisioning state and it becomes active, and all of those will be part of the events list when you describe the CR what you created. So the name of the CR will generally be this value, MySQL DB system -sample. And that is, once you have this done, you can go to the console and go to the respective compartment, and you should be able to see a MySQL DB system in the provisioning state if your describe says that it's getting provisioned. So you should be able to see that there. MySQL DB system takes quite some time to get provisioned. I've seen a turnaround time of 15 minutes. I don't know if it's any better. It takes a good amount of time before it comes to an active state. So once it is back to an active state, you can directly start using it. For you to access the MySQL DB system, as we discussed previously, the admin secrets contain the username and the password. You can directly mount this secret to your app and consume it in your app for accessing the MySQL database system, initializing, and all the other things. So this is how you actually go and provision MySQL DB system through OSOC. So I'll pause here for 2 minutes to see if you have any questions or any doubts regarding this. And one more thing which is not present in this lab session, which I would like to call out is, this is not just about creating MySQL DB systems. You can also go and bind to an existing MySQL DB system as well. So the instructions on how do you create YAMLs and other things are part of OSOC and open source repo. So I would share this in the chat for you guys to go look at it. It contains instructions on how can you bind to, or you can also bind to an existing DB system. So what is the major thing what you would need there is you would be needing the OCID of the MySQL DB system what you provision. So once it gets bound to an DB system, you do have privileges to go modify it and manage it using OSOC. That is, whatever is the allowed updatable field by MySQL DB system, we allow those fields, be it admin credentials. I don't know if credentials is updatable, but display name and other configuration, like configuration, if you have to scale this up to some other new configuration, all of this becomes updatable even for an existing DB system. You can bind to it and be able to manage it better. So yeah, I'll give 2 minutes here for us to see if you have any questions. I don't see any questions, so I think I'll proceed with the next lab, that is provisioning an autonomous database system using OSOC. Yeah. Okay. So autonomous database, Oracle autonomous databases. So there are multiple flavors which is offered by Oracle autonomous databases today. We support 2 of them. One is transaction processing and one is data warehousing, and they are differentiated when we try to create them. in their YAMLs. And the provisioning aspect is very similar to what you saw in Oracle MySQL DB. But there are a slight changes with respect to autonomous database on how the passwords are retrieved, valid passwords, and how can they be mounted onto your app. And there is nothing like a pre-configured configuration in autonomous databases. So without any delay, we can get started. So again, here it's the same thing. What we are doing here is we are creating a new policy for us to manage autonomous database, for OSOC to manage autonomous database in your tenancy and in your compartment. So if you see, this is what we have to be using. As I said, if at all you will be using user principles, this conditions, this statement will change. You will be like allow user your username, or allow user group your user group name to manage this in your tenancy. So that will be the differences there. Since we will be using instance principles, this is the policy you will have to add. You can either add or create a new policy, or you can actually go to the previous policy what you created, edit the policy and add this new statement there. Either of it will work. So it is all at one single place. It is a choice or an option to the user. Talking about provisioning an autonomous database. So in autonomous database, there are two parts to it. One is your admin password, one is your valid password. So here username is always by default admin. So there is no change to it. And so we are just taking only what is required by the API, that is just password. Again, the same thing here. You will have to be giving the password in a base64 encoded format, and you can use this to create the password. This will be substituted with the name what you want. This formatting is little weird, where you will actually have a space here. I don't know why is it not coming up properly. But yeah, there is a space here, and then hyphen from hyphen literal equal to password equal to this is the value. So this is right. And similarly, you will also be creating a valid password and a valid password, secret name and valid password. One thing to note here is again the formatting. So here the valid password where P will be capital, you will have it very similar to what is there in this. So yeah, there is this slide formatting. Please keep a note of it when you are creating a valid password for your autonomous database. And coming to the YAML, a sample YAML. So here again, most of the details is same. I'll walk you through individual. So this will be the name of the CR, what you are going to be creating. Like how we saw in the previous lab, it was called as MySQL DB system hyphen sample. You can give a new name to it, what would suit that particular autonomous database CR. And this is the compartment where you want to provision the autonomous database in. And this is the display name of your autonomous database. They both need not be the same. You can choose to have a single database and multiple CRs to it. So as I said, we can bind to an existing databases as well. So keeping them different is a option what user has. And the DB name is the name of the database which will be created. So this is the display name in your console, and this is the database name, autonomous database name. So this is the differentiator about the type of autonomous database. OLTP refers to processing flavor of autonomous database, and DW refers to data warehousing flavor of autonomous database. And these are some of the other required thing on what is the DB version, is it dedicated, and data storage in TBs, CPU core count, what you need. And this is your admin password secret name, the name of the secret what you gave previously. You can give this here, and you can also choose if you want to if you want to enable auto scaling or not, and is it a free tier or not. And licensing model also can be specified, where you can either use these two enums, bring your own license or license included. And for valid, so this is interesting where you can specify the name, valid secret name, and the valid, the valid name and the valid secret name. So the valid name will be the place where you will have a secret created for you in your Kubernetes cluster that you can use to mount to your application. For example, let us say I create an autonomous database underscore valid new as the name of the wallet. After MySQL DB system is provisioned and is active, OSOC will download the wallet using the wallet password, and it will create the secret what you can directly mount onto your app and directly consume the wallet. So you don't have to be messing around with credentials, and it is more secure for you to create it with a secret. And this will also help you, aid you in deployments where once you define a name to the secret, you can use the same secret ref in all your deployments as well, so that there is a lot of ease when we are actually writing a single deployment YAML for the infrastructure as well as our application. So this is the secret name, what we have created in this step. And once this is done, these are free-form tags and defined tags if you want to add anything to the database. So this is a sample YAML, what we have for you. This is how you, these are all the various things what has to be provided. And once this file is created, you can use kubectl apply -f and go and create it. One thing again here is, let us say that you already have an autonomous database which is running and you know the OCID of it. You don't have to specify most of this. You can just pass on the wallet info alone for you to download the wallet and start using it. So you can just give the OCID of your autonomous running existing autonomous database and give the wallet. Similarly, we will go bind to this particular autonomous database, download the wallet for you, and make it available in a secret with the name as sample adb-wallet, which can be used in your application deployment. So this is another value add what we have for autonomous database and other OCI services. So once this is created, so autonomous database is the container custom resource definition what we have created out of OSOC. So when you do kubectl get autonomous databases, you will be getting this output where it will tell the name of the CR what you gave, the workload type, the status of it, and the age of the CR. And when you do an hyphen output wide, you will also be getting the display name along with the OCID of that particular autonomous database. And a describe of this autonomous databases, it'll give you everything, or you can use the name of this here, and you should be able to see all the events of whatever the state of that autonomous database is. It's in provisioning, active, updating, and all the other things. Again, as I said, there are sample YAMLs in the link, GitHub link, what I shared, that contains YAMLs for you to update an autonomous database. Like you can update the data storage, display name. There are a bunch of fields what is allowed by autonomous databases for you to go update. So you can use that sample YAML and try to go and do updates as well and manage it completely. So this is mostly what we have in this session. I would like to give some time for you to ask me any questions on autonomous databases. And I think, yeah, that's all is what I had. So if you have any other questions also, I'm open for it. So I just answered one. So there was a question which said, what is the benefit of provisioning autonomous database or MySQL DB service through Kubernetes? So the major advantage here is today we know that there are a lot of tools available to us in the market for us to put our infrastructure in code and manage it via code. So for a person who is very for a developer who is very used to this apps of customer native apps, he would be very familiar with YAMLs. So we thought of giving that an opportunity, like giving those developers an opportunity to go even manage the OCI resources. You don't have to switch between console or CLI or Terraform or any other tools to do it. What if we can bundle everything into a single thing? So when you're running your deployment of your app, so as part of the first step, you can actually go provision the necessary infrastructure for it and then consume that directly into your app. In case if it's in a console, you will have to provision it, then download the wallet, take those details, put it into a secret, and then share the secret with the app. So there is a lot of manual work. So this would help you to automate a lot of things. That is the advantage what I have, what I see. Okay. Bharat says I have a question, but there's no question there. So okay, please recap how to install Kubernetes. Pradeep, can you clarify, is it install Kubernetes? Because we don't install Kubernetes, we are creating an OKE cluster, which is a managed Kubernetes cluster. It is by default installed. It's a Kubernetes cluster. Where do we host the wallet? We don't host the wallet. We download the wallet and create a Kubernetes secret in your cluster. And this secret can be referenced in your deployment YAML of your app, very similar to what we have done here. So if you see what we did in the steps was, we created a secret and we gave some values. So when we tried creating this resource called autonomous database, we actually did not pass the secret. We said, this is the name of the secret. Please go look for the secret and that value what you want, and that will actually have the details so that it is safer. You don't have to actually pass those in the YAMLs. Similarly, you can use this in the wallet as well for your apps. Okay. The secrets, how to add multiple users, and on Oracle deployment, how to manage persistent volume in Kubernetes. In terms, hey, Bharat, I am not very 100% sure on your first part of the question, which says in secrets, how to add multiple users. Do you mean like creating new users to your database? If that is the case, I am not very sure on if that is accepted in the autonomous database today. Today, from the APIs, when you create an autonomous database, it allows you to create admin user alone. Or if your question is regarding access to the secret by multiple users, once a secret is available in namespace, multiple users can go mount it into their application and go with the deployment. And on the second part of it about persistent volumes, I think you're talking about block volumes. We are yet to support block volumes in OSA that is being built, and we will see a new release very soon with that as well. Okay, can we migrate pre-existing autonomous to manage the Kubernetes? Yes, Sumit, the answer is yes. As I was talking about, yes, you can use the OCID of your autonomous database and MySQL DB systems and create CRs. And once that is created and once you see that active, it is being managed, then you can go update the values of those two resources through OSOC, through Kubernetes. Why do we need to install Operator SDK? We should be able to directly install ORLM and Operator itself. Hari Babu, you are absolutely right. Yes, you can do it. So here we thought of just giving you steps to install it through Operator SDK. And one more note on that is, I have seen people directly installing OLM and having issues because OLM, their support today for direct installations has become little messy. So Operator SDK in way of installing OLM is much more easier and manageable is what we thought. So that is the reason we thought of using Operator SDK to install the OLM. And even if you install OLM, for you to run the bundle and other things, you need Operator SDK. So Either ways, you need an operator SDK to do it. So that's why we thought of having the session steps with that. So that's all is what I had in the lab session. I'm open for Q&As and any more questions if you people have, I can help you answer them. Can we install this operator in normal K8S cluster or only in Oracle? Yes, you can install this in normal K8S cluster. So this does not have any OKE specific things in it. Just few things to note here is in a normal Kubernetes cluster, you will have to look out for the subnets and other things what you have configured. So those values you might have to do it. So it will not, you cannot use as is directly with the tutorial what we have, but this is possible for you to run in normal Kubernetes cluster or any Kubernetes cluster.
Thank you, everybody. Bye-bye.